Okay, so we went through and figured out what the future value of a single sum is. Now we're going to go, now we're going to look at how to calculate the present value of a single sum. So remember, the unknown is what it's currently worth. We know what it's going to be worth in the future. We want to know what it's worth right now. This is so the value of a given amount to be paid or received in the future, assuming compound interest. So this is the scenario where I need to have $5,000 in 10 years. I know my interest rate is 4%. How much do I need to put away right now in order to have that in 10 years? If you're saving for college, maybe for your children, you're already in college, but maybe for your children, you figure I got 18 years to save for their college. I've got one sum to put in right now. I want to have $20,000 at the end of this, and I know I can get 5% interest. How much do I need to put in right now? So that's where this comes in. Here is the equation to figure that out. What we have to figure out is that factor. So we know what the future value is. We need to find out what the factor is in order to determine what the present value is of that single sum. So here's an example. What the present value of $73,466 to be received or paid in 5 years, discounted at 8% compounded annually. All right, before we look at so here's the calculation for it. We're going to go through and do use the tables here in a second. So we know this is the future value. We know what we're going to need. We need to find our present value factor. Now to find our present value factor, we take 1 divided by 1 plus the interest rate to the power of the number of compoundings. In this case, it calculates out to 0.6058. But you know what? Let's look at our table and see if we can't find that on our table. Okay, so now I'm using the second table here. I'm using the present value of 1. So our factors, let's write these down here that we're using. So we have 73,466. That's our future value. That's what we're going to have in the future. 5 years, annual compounding, so once per year, at 8%. Okay, so we got 5 years. We have 5 compounding periods at 8%. Whoops, I'm on the wrong. Flip over. We only go to 6% on this particular one. So we're going to go to the next one. This is just a continuation of that. So 5 periods at 8%, our present value factor is 0.68058 right here. Go back, you can see this, 68058. If you do the math, that's what it gets. The tables, of course, give you the answer a lot quicker. So if we were to multiply this times 50,000, we come up to about, that times 73,466, then we get about 50,000. Okay, and they had to do some rounding here. So if we were to, let's just see the math. So we'll take 73,466 times 0.68058, 49,999.49 cents. So that means if we want $73,466 in 5 years and we can get 8% compounded annually, we have to put away right now $50,000 in order to get that. All right. So, and this is just going through what we did. So we use that same table, 8%, 5, and they came up with, there it is on the table. Okay, so that's everything that we just did. Now, let's go through this problem. So assume that your rich uncle, don't we all wish we had a rich uncle? Assume your rich uncle decides to give you $2,000 for a trip to Europe when you graduate from college 3 years from now. He proposes to finance the trip by investing a sum of money now at 8% compound interest that will provide you with $2,000 upon your graduation. The only conditions are that you graduate and tell him how much to invest. All right, so let's figure this one out together using our table. Get this off of here. What did we do before sticky notes? All right, so $2,000 for a trip to Europe. I'm not sure that that's going to get you, that'll get you your plane ticket. That's probably about it. 3 years. Okay, I think it's compounded annually, 8%. So what are we going to need? So let's take a look. So 8% over 3 years. So we've got 3 periods, 0.79. So the present value factor is 0.79383. So if we multiply that by the 2,000, then we get times 0.9383. $1,587.66 is what he needs to put away right now. Okay, let's see how we did. All right, so here it is. $2,000 is our future value. Our factor is 0.79383. Sorry. Present value is $1,587.66. So if that's how much he wants to give us, he needs to put away $1,586.66 so that he has that $2,000 in the future. Okay, so that's the present value. Same idea as the future value, only we're kind of working backwards. In the upcoming slides, we're going to solve for some other unknowns. So maybe we don't know what the interest rate should be, or we don't know how many periods, how long we should be compounding it. So if we know the present value and future value, we can solve for some of those other unknowns as well.